Hello and welcome to 100% Real with Ruby. Today I have Gab Fundaro on and we went deep into gut health. We bust quite a few myths in this one and it's split into two episodes. So in the one you'll be hearing next week, we actually go a little bit more into how your mindset and your perception of food and stress in itself can impact your gut health and create issues down the road. If this is something that you enjoy, please share it with someone who needs to hear it, who wants to know about gut health. And don't forget to click through to my podcast and give it a 5-star review. And I hope you enjoy it. Hello, and welcome to 100% Real with Ruby. Today, I have Gab Fundaro on my podcast today, and she's the doctor of all things amazing with gut health. And it's a massive topic out there, but it's become this woo-woo thing these days where people are just like, oh, let's not talk about gut health. There's too much crap out there. There's all these functional practitioners that are trying to sell you products and do these silly tests, but this is the same with any field. There is the negatives, there is the positives. There are people that take things too far, and then people that just say, oh no, it's just about the calories. Oh no, it's just about the hormones. Everything impacts each other, and the gut is like the center of everything. Without your gut, you're not absorbing any of the food. So where are those calories going? Where are those calories getting absorbed to get turned into energy? So with that, I'm going to let Gab introduce herself and lead into a very controversial topic on how things like the carnivore diet and even keto can impact your gut microbiome, and not in a positive way.
Absolutely. So I am Dr. Gabrielle Fundaro, and it's so fun to hear like my Australia friends say Gab, because that was like my name over there. And I think for people who aren't aware, like from what I noticed, there's kind of like a culture of like changing names. So if you have like a long name, it's changed to one syllable, but if you have one syllable name, they're going to add one to it. So I love that. So my background is both in exercise science and then the link between the gut microbiome and skeletal muscle metabolism. So this actually segues really well into answering the question, because my doctoral dissertation focused on the effects of chronic high fat feeding on the gut microbiome and metabolism, and whether probiotic supplementation might be able to protect against some of the unfavorable changes that happen in skeletal muscle metabolism when a person is eating a hypercaloric chronic high fat diet. But when we look at the effects of something like a fiber and carbohydrate deficient high fat or high protein diet, it's a little bit tangential to that. But in essence, what we're seeing is that microbiome that doesn't have access to microbe accessible carbohydrates that come from our diet in the form of fiber and resistant starch, they're going to look to other sources of energy for themselves. And those alternative sources of energy are primarily going to be glycans, which are carbohydrates that are in the mucous lining that covers our intestinal cells, and then also dietary proteins. So there are certain groups of microbes that can ferment peptides, or small groups of amino acids, and they can produce energy that way. The issue with those forms of energy production are that if they are breaking down the glycans in that mucus layer, they're actually making the mucus layer thinner, and that's reducing part of our immune system, essentially, because that protective mucus layer helps to create a barrier between what's in our intestines and our intestinal cells and the underlying immune cells. So this has definitely been seen in rodents. We don't have as strong of evidence of this phenomenon in humans, because it's really difficult to take out to take biopsies. I mean, we can biopsy the mucus line, the mucus layer, but it's much easier in a mouse model where you can just like take a cross section of the intestine out and look at it under a microscope. We can't do that in humans. But there's a lot of mechanistic data. There's a lot of preclinical data, so that we could be reducing the thickness of that mucus layer. The other issue is that proteolytic fermentation, so using proteins or peptides to make energy, produces some carcinogenic byproducts like p-cresol. So those have been associated with an increased risk of colorectal cancer. This is not to say that protein causes colorectal cancer. That is not at all what I mean to say. But it's still important to keep in mind that when we're looking at a long-term dietary pattern, and potentially the accumulation of these carcinogens or the repeated exposure of these carcinogens, that, along with other lifestyle factors, could increase someone's risk of developing colorectal cancer. So when we starve our microbes of dietary carbohydrates because we're either eating a really, we're eating a carnivore diet, or we're eating a ketogenic diet that isn't prudently planned out to include enough fiber, that we could be seeing those changes occur. The other thing that happens is that the microbial community changes. This has been seen and replicated multiple times in humans. If you take a human or a group of humans and you place them on a fiber deficient, very high animal product dietary pattern, within 24 hours, you'll start to see changes that are going to bias more toward those microbes that can engage in the proteolytic fermentation and that can degrade those mucin, that mucin layer. Those microbes are going to increase in number, and like the relative abundance, the proportion is going to increase. And the microbes that require carbohydrates to produce energy, those carbohydrate fermenters, those are going to die off pretty readily, or pretty quickly, because microbes have a very short lifespan. So within about 24 hours, we can see these changes occurring, and they can last up to 5 days to 7 days is usually the length of these interventions. Longer term studies that have looked at dietary and exercise interventions find that even if someone has changed their diet and their exercise habits, the microbiome does revert back to at least to some extent, or like very close to where it was beforehand. So the jury is still out on whether those initial really significant changes are going to be sustained for the duration of someone's carnivore or ketogenic diet. But when we look at really large long-term observational studies, what we tend to find is that a prudent dietary pattern like the DASH or Mediterranean style diet is associated with about a 20% lower risk of colorectal cancer than a westernized diet. So westernized diet is characterized by a lot of refined carbohydrates, really low in fiber, obviously going to be low in things like fruits and vegetables. So that doesn't obviously directly replicate a carnivore or ketogenic diet, but a lot of evidence suggests that really what the issue is that lack of dietary fiber, and that the microbes either die off or they have to find alternative sources for energy. And when they're using those alternative sources, not only are they potentially increasing carcinogens, they're not producing beneficial short chain fatty acids to as much of an extent either, because most of those short chain fatty acids, especially the ratio, that production is going to be influenced heavily by the carbohydrate fermenters. A lot of them are going to create butyrate, and that's really beneficial short chain fatty acid. So the big takeaway is that if you're eating a diet that is not providing adequate fiber, no matter what the dietary pattern is, whether you're eating a westernized style diet or a carnivore diet, not only are you increasing your risk of disease and producing some potentially harmful compounds, you're also not producing as many of the beneficial compounds.
So another key message that you were reiterating in that is that the gut can change like within 24 hours. So it's not too late to revert back to obviously a more abundant diet that's full of different colors and not just one type of fiber, which I'll get you to explain later as well. But the thing is, the changes that you make to your diet has consequences on your body. And although the gut can change within the 24 hours, it does take time for then the consequences to revert back to normal. And we mentioned that there are these cancer risks from not having adequate fiber in your diet, which is the majority of people, regardless of if you follow a prescribed diet trend or not. Most people are not eating enough veggies. And maybe it's from some food trauma in the past or whatever it was that had you turned off veggies. But there are different ways that you can include veggies into your diet to start to actually have a more healthful life, but they do take time to revert. So with fiber, it is really important to understand the differences between them as well, because too much of one and not enough of the other can lead to imbalances there as well. So maybe you can speak a little bit more on that too.
Yeah, so those the microbe accessible carbohydrates are largely found, as I mentioned, in different forms of dietary fibers. Probably a lot of people are familiar with the term FODMAP, so that's fermentable oligodimonosaccharides and polyols. So not all of those are considered to be fibers, but they're all considered to be microbe accessible carbohydrates. And most of them are going to be soluble fibers. That means that they attract water. So if you were to put them into water, they would be kind of like, they would become mushy. You can think of like oatmeal as an example. So those are highly fermentable. And then we have the insoluble fiber, which are things like fruit and vegetable peels. So if you put them in water, they just maintain their normal structure. Those are also potentially, they are microbe accessible, but they're not as easily fermented. So they're not as much of like a preferred energy source. So, and then there are resistant starches. So those are starches that we could, our enzymes can act on to some extent. But most of them will also pass on to the large intestine or the colon with those dietary fibers. And then those are going to be primarily what's fermented, and then they can go on to be produced, used to produce short chain fatty acids. They can also result in gas production. So sometimes that's why people will feel kind of gassy and bloated if they eat a high fiber meal. And these FODMAPs are especially fermentable. And so in people who have something like IBS, that they're already going to be really viscerally hypersensitive because of the activities of their intestinal nervous system, that gas production is going to potentially be really, really bothersome. And those FODMAPs, because they're also soluble, they can pull water into the gut, and then that can lead to stool changes as well. So ideally, what we have is a blend of both the soluble and insoluble fibers, so that we can have bulk to the stool, but also pull in enough water, not too much, and that we're also providing a different, like a wide array of those fiber sources, because some microbes will preferably use inulin. Other microbes may preferably use like a mannitol. So there are different, like it's kind of like when you think about eating the rainbow, we don't say that just to like, not just to have a colorful diet, because then you get a wide variety of foods. It's not just about that. It's about the colors represent an enrichment of different phytochemicals, and that increased diversity represents a diversity of fiber sources or types and a diversity of micronutrients. So there really is a lot more to it than just like, okay, this is a cue to help like eat, different fruits and vegetables just because it's good for you. Like there are many layers to why it's good for you.
Yeah, so something that I could suggest as a tip as well, so you're not overcomplicating your food choices, is just to look at what you're currently eating and see where you could make switches to increase the different variety within that. Like instead of having one grain of something, there's a multi-grain of something. Or if you have like a packet of veggies that's just one vegetable, get mixed vegetables. Then you can still eat the same foods on like the same similar foods on a daily basis and still cover all your needs, because you're eating the same thing, but something that's not just one, like unifocused. You can pack it all into one. But speaking of fiber and FODMAPs, we can touch on now the consequences of too much fiber, but also the woo-woo of intolerance tests. And the frustrated, like when people get intolerance tests and they get passed on to some naturopath that then tells them to avoid all these different foods, which, oh, surprise, surprise, it was all the foods that they were just currently eating quite a lot of. And I'll let you explain the rest.
Yeah, absolutely. So yeah, so food sensitivity testing, I think that it seems to be subsiding, hopefully, but for a while it was like a really huge trend. And a food sensitivity test claims to be able to detect food sensitivities based on your IgG response to different foods. So the IgG antibody is an antibody that your immune system uses to recognize different proteins. It's essentially like a name tag. And while this test does measure IgG antibodies, the problem is that IgG antibodies are associated with tolerance to a food, not an allergy and not an intolerance. It's actually a recognition antibody to say, oh yeah, we've eaten this a bunch of times, like it's fine. This guy's cool, let him through. And this is the way that a lot of alternative medicine or functional medicine style testing works, is that they take a test that has been validated to measure a specific metric. Like, yes, it measures IgG antibodies, or yes, it can accurately detect, concentrations of this mineral in your hair, or yes, it can accurately detect, or quantify this white blood cell, or whatever it is. It is the interpretation of the test, or stool analysis tests. Like, yes, we are, to the greatest extent possible with the way that these tests work, quantifying a specific set of microbes. But it's the interpretation of these tests that is inaccurate and that is pseudoscientific. So when we look at the IgG food sensitivity test results, we're getting a list of foods that our body has seen many times and is tolerant to. Now, coincidentally, one or more of those foods could be something that you have an actual food allergy to, and that would require a screening tool and an oral tolerance test with an allergist or an immunologist, depending on where you are in the world and what they're called. And that uses an actual allergic response is going to use either an IgE antibody, or it's not going to be an IgE or IgG mediated immune response. So you could actually have a food allergy, but that's not the test that you would use to determine that. Now, if you have a food intolerance, that has nothing to do with the immune system, and that's just the lack of a digestive enzyme that you need to break down something in that food. So lactose intolerance is one of the most common forms. That's basically you don't have lactase, which is the enzyme needed to break down lactose sugar that's found in a lot of different forms of dairy. Since you can't break that down, it is made more available for the microbes, and they'll ferment it and create a lot of gas. There are other intolerances that are less common. Like, some people don't produce sucrase. That's really, really uncommon, but in that case, the person wouldn't be able to break down sucrose. So they would have a lot of GI distress just from eating like any source of sucrose, which is like any simple carbohydrates and things like that. And then you may have an intolerance to something like a FODMAP that is universally malabsorbed. So, for example, when we look at sorbitol, that is a sugar that is universally in all humans poorly absorbed. So if you eat enough of it in one sitting, it will have a laxative effect. I point out sorbitol because that's used in a lot of diet foods. It's used in place of nutritive sweeteners because it is a less nutritive sweetener. I think it only has like 2 calories per gram instead of 4, like table sugar would. So if you have maltitol is another one. So it is a less nutritive sugar. It's a sugar alcohol. So if you are eating a lot of like sugar-free products, you could actually be eating a lot of these sugar alcohols that would cause a lot of gas and bloating and loose bowel movements. We also see that with inulin. So that's a functional fiber. It's an isolated fiber that's shown to be beneficial in humans. And that's found in under other names, like you might see it under chicory root. And that can also cause a lot of GI distress because, again, it's just a really potent FODMAP. So these are, ironically, would be considered, inulin in particular is a prebiotic food. So prebiotic means it's a preferred energy source for beneficial microbes. So you could say it's like, quote unquote, good for gut health, but like subjectively, you will feel very bad in your gut if you have a lot of inulin or really, a lot of any one of these FODMAPs in one sitting, in most cases, they're going to cause at least some level of GI distress, some gas and some bloating and loose bowel movements. Doesn't mean that there's any harm coming to your GI tract. It's just that is like one aspect of kind of gut health is, our subjective experience of digestion and elimination. But you can have really uncomfortable GI symptoms and have like nothing wrong with your actual gut, and your microbes are just doing what microbes do, just, happily fermenting.
It's not always going to be 100% all the time, every single day. So that's something to take in mind as well, because if you put it onto yourself that it's almost like you expect yourself to have a perfect sleep every night, the perfect day every day, the perfect gut health, the perfect poo, and then 1 or 2 days off and it's like a catastrophe. But you have to keep in mind that there are ups and downs in everything, and one bad day isn't a means of concern, or maybe even 2. It's trends over time. And you mentioned sorbitol, and I guess this can also feed into like emulsifiers in food and other things that people might point at in a lot of processed foods, and how that can also impact not only the gut, but then how that sort of the receptors can sort of feed into the brain and make it like really difficult to stick to any plan because of the cravings and stuff.
Oh yeah, in terms of like having a really refined diet.
Yeah.
Oh yeah. So actually, there was a really interesting study that was just published. It is still it hasn't been peer reviewed yet. So I just want to make that mention. I think that's an important caveat. That if this piece of literature is floating around and you go look for it. It hasn't been peer reviewed as of today. But what they did was they put people in a metabolic ward. And so it was very tightly controlled. So in a metabolic unit, you just live in there. And then they use some method of calorimetry to determine how many calories you're expending. In this case, they collected stool so they could see how much energy was lost in the stool, and they fed them a very a controlled dietary pattern. So, and these people, it was also a crossover design. So the people they lived in the unit for a week, and then they had a 2-week washout, and then they went back for another week. And the treatment was either a minimally processed, I think they called it a microbiome reprogramming diet, but it was just a prudent, minimally processed dietary pattern with a variety of fiber, with adequate fiber intake. And then the other diet was a macronutrient, highly processed style diet. So we wouldn't necessarily say it's a westernized diet because it wasn't as high in dietary fat. They wanted to make sure that the macronutrients and energy were matched, and that they were eating at what should have been like a caloric at a maintenance level. So we got one group that's eating, this sort of like highly refined, super processed diet, and another one that's having a less processed diet. And they wanted to see how it would affect the microbiome and how it might affect things like short chain fatty acid production and the amount of energy that's actually absorbed versus what was lost in the stool. So what they found was that the people who were eating the less processed diet actually absorbed a little bit less energy. It was about 115 calories per day on average that they absorbed less compared to the people who were eating the highly processed diet. So the highly processed diet, all of those calories were available for absorption by the human. Whereas in the less processed diet, where there was more dietary fiber, less energy was actually available to the humans. Now, there's a really interesting caveat here, because in the group eating the minimally processed diet, they had a lot more fiber available. And because they had that fiber available, those microbes were able to ferment that to short chain fatty acids. This process is called energy harvesting. When microbes take something that's not digestible and absorbable to humans, and then they convert it to something that is absorbable, short chain fatty acids. That, like previously, the theory was that, well, maybe people who develop obesity have an obesogenic microbiome. They have a microbiome that's very good at energy harvesting. They create a lot of these short chain fatty acids. But this study indicated that even though they produced more short chain fatty acids, and there was a greater percentage of energy from those short chain fatty acids, that still the net loss of energy in the feces was high enough that it was higher because there was just less energy that was absorbable by the humans. Like the microbes still weren't able to release absolutely all of the energy that was available in those foods. So the take-home message there is that potentially the amount of processed food that you're eating, even if we are at an energy matched place in terms of our intake, like we're really tracking calories, that you may actually be absorbing more calories or more energy from that diet. I don't want to say nutrients, but more calories from that diet compared to eating a diet that is energy matched, but less processed. And that could be a change, you know, these people, because it was such a short period of time, they didn't lose a significant amount of weight, but it was like, you know, no weight loss in the highly processed group on average versus about 200 grams after, you know, a week in the minimally processed group. But if you think about that long term, you know, like 200 grams per week, that can add up if the only change that you make, you don't even have to, you know, change the amount of macros. You don't touch your macros. You just say, oh, I'm eating a lot of like highly processed foods. Maybe I'm going to switch to less processed foods and just see how that goes. And maybe that could translate over time to some loss, but not necessarily, because some people can energy harvest, you know, an additional 200 calories per day, and some people energy harvest 0 additional calories per day. And there's no way for us at this point to be able to program your microbiome, you know, to do one or the other, like long term. It really is a result of what you're eating mixed with whatever your combination of microbes is. We don't know yet, like which microbes we would want to have on board to, you know, not have any extra energy harvesting. And like maybe that wouldn't even be a good thing. So I just want to put that out there. Like, yes, we're exploring these things and it's really interesting, but like if someone's trying to sell you some kind of reprogramming protocol, it's nonsense.
Metabolic reprogramming, that sounds like something that will be a trend soon. But
sure.
Yeah, this whole conversation right now is really exciting me because it just reinforces everything that I preach every single friggin' day, that your food quality matters. There is the thermic effect of food, and the more processed a food is, the less calories it takes to digest it. And then there's protein. Again, if this was not like in a ward, the people that were on the higher processed diet would have ended up pretty much obese in time to come, because those foods, like we were saying, will increase the cravings. It would become, I want to eat more, because there's going to be no real stop to something so highly palatable that's designed to make you want to eat more. Mm-hmm. The higher satiety is going to make the diet easier. And one question on what you said with the feces thing was, were you relating to the one where they took the poo transplant out of the obese rat and put into the other one?
Oh no, that's a different, yeah. So they didn't do that. In this case, they just measured that energy loss in feces. Yeah.
The one that you referred to in saying that in the past, that's what they thought that there
was. Yes, exactly. Yes. So the fecal, the fecal transplants. So that was really a groundbreaking study. And at the time, and not to say that there was anything you know, terribly wrong with those theories at the time, because it was based on those rodent models. What they did was they took they took a fecal transplant from a mouse with obesity. And I want to point out that these mice have developed obesity because they are genetically modified to develop obesity, and also because they're fed a high fat, high sugar diet, and that is hyperphagic. That just means that, like, a rodent will eat more of that food compared to the regular rodent chow. So they're designed to develop obesity. And they transplanted their feces into germ-free rodents. So those are rodents that are born and brought up in a sterile environment. So they are essentially empty. They don't have gut microbes. There are a lot of issues with those rodents anyway, and like rodent models in general, in terms of like microbiome studies, are for mechanisms, not for translation. But those germ-free rodents then went on to develop obesity. And whereas if they transplanted from a lean rodent, the recipient wouldn't develop obesity. So it looked like microbiomes, that almost suggested that there was a causative link there, that like your microbiome could cause you to develop obesity. So of course, logically, it was like, all right, well, translational research, we need to do this in humans. We need to do some fecal transplants, and this was going to be the next cure and whatnot. And they've done that in humans, and it is not the case. If you do a fecal transplant from a lean donor into a person who has obesity, some of their metabolic markers might improve and there might be a lasting change to the microbiome, but it does not cause them to then no longer have obesity. Their BMI will remain the same. And actually, some other interesting findings have been looking at like the effects of weight loss on the microbiome and how the microbiome might play a role in weight loss or weight loss maintenance. And it does look like there is some benefit to giving someone their own fecal transplant post weight loss. So after a weight loss diet, you've lost weight and you've also had a change in dietary pattern, there's going to be change in your microbiome, which, as we mentioned before, will revert back to baseline, and that seems to, in some cases, correlate with weight regain, but not always. So it's not a causative thing. But
I want to reiterate one thing in here. Yeah. This is why it's really important to develop habits, behaviors, and strategies to keep the weight off and not to just lose it only to gain it back again, because your body will always revert to what it knows best. Yeah. It is a long process. The more that you rush it, the faster you're just going to end up back at the start. So stop friggin' rushing the process. Continue.
Yes, yeah, absolutely. So there was a study in which they gave people their post-weight loss fecal transplant over the course of, I want to say it was like 6 months post-weight loss. And that seemed to help maintain some of the metabolic improvements. But, over time, they still regained at least a portion of that lost weight. So there still doesn't look like a fecal transplant is really going to be super beneficial for weight management, at least not at this point. Like, we haven't refined it to that level yet. And as I had mentioned before, also, even in the people who maintained dietary changes and exercise habits, their microbiome still over time kind of reverted back to baseline. And it's probably because our microbiomes are not just shaped by our dietary pattern or exercise habits. They're shaped by gender, age, geographic location, medications we might take, people and animals that we're in contact with, our tap water, like literally everything. And so, and that's part of the reason why they're so complex and it's so difficult or impossible to kind of like hack them or farm them in any sort of way that is super beneficial to us. And to, look at kind of just that long term, like what is the dietary pattern that I can follow long term that is ideally very nutrient dense, reduces my risk of disease, provides these microbes with the energy that they need to create, to support this relatively resilient ecosystem, and not look for like a quick fix on everything.
Which is clearly not going to be carnivore or a terrible keto diet. So keep that one in mind and make sure that you are eating a lot of plants. And it's almost like Luke Lehman, you would know him. It's almost like Luke Lehman says, eat a vegan diet, but then put meat on it.
Okay, so funny enough, I do know who he is. And I said that, I want to say it was in like might have been 2019, in like early 2019 that I was presenting in New York. And I'm not saying that I said this first, but I may have. But I was presenting in New York and I was like, we want to eat a vegan diet. I essentially said that. I was like, eat a vegan diet, but like you can add animal proteins if you want. Like, then that really is it. Like, that's just that plant forward dietary pattern. And yes, if you want to add in some animal proteins, it's probably better to go for things like fatty fish and poultry, and limit your intake of saturated fat and processed meats, and maybe limit your intake of red meat. But you don't have, like, there is not a clear advantage to being vegan or vegetarian when we're looking at the gut microbiome. I think I've only seen one. It may have been a meta-analysis. One meta-analysis, I think, found that there was a slightly reduced risk of, I think, like luminal colorectal cancer in people who were following a vegan diet. So no, I'll add that out there as well. But like across the board, when we're looking at vegan versus vegetarian versus prudent omnivorous, that it looks like as long as you're doing either one of those in a prudent way, that you're going to be good to go. And we could say that, if a person's trying to follow a vegan diet, that requires thought and planning just as much as a prudent omnivorous diet would.
Yeah, I would always put my hands down and vote for the omnivorous because of the high, like the beneficial, the benefits of actual animal proteins, because dairy is actually really good for the gut as well and for your health. So that's something to keep in mind. Dairy is actually beneficial. It is not something that's loaded with friggin' hormones and whatever you want to think there is.
Right.
I think it's actually, no, egg and dairy are like one of the top quality protein sources out there as well. So there's something to keep in mind. Even though if you have an egg, you have to realize it's just like salmon. 50% of it's fat, 50% of it's protein. So look for the actual protein percentage of the whole calories when it comes to protein sources. Because if you're in a diet, you're going to want to go for like the leaner cuts of poultry and whitefish and stuff like that.
Yes.
My favorite part. You mentioned the extractable energy, which leads me to the next topic, and chronic dieting, undereating, over-exercising, how that can make you have more extractable energy and how your microbiome can absorb more calories from the food that you eat when you're in this prolonged dieting, prolonged stress state.
Yeah, absolutely. I think it's really important to point out the address the confusion that can happen and address a lot of the myths as well. Because I know that when people, and I have been there myself, but it's kind of like you get to this place where, in the past, it seems like you lost weight so easily and now you're at a plateau and it feels like you're not eating anything and your exercise is the same. You're still going to the gym 5 days a week. Then maybe your metabolism has slowed way down. That's probably not the case. James Krieger has put out a lot of great information on this topic of metabolic adaptation. But it does look like there is some. So you might be burning, 75 fewer calories, I think was the average that he found per day. Depending on the amount of weight that you've lost as well. So we'll imagine that this is an appreciable amount of weight loss. So you have some reduction in energy expenditure, but it's pretty minor. You have a slight increase in potentially energy absorption. You could have some reduced motility of your GI tract. So essentially it keeps food in there longer to try to extract as much energy as possible. The biggest change is going to be your NEAT, your non-exercise activity thermogenesis. You might be still going to the gym 5 days a week, but you probably aren't exercising as intensely. And then what are you doing for the other time? Are you still fidgeting and putzing around the house and things like that, or are you kind of parked on your couch, or you're sitting at your office desk because you're really tired because you've pushed your calories as low as you possibly can. Long term, there haven't been very many human studies that have looked at the effects of long term energy restriction and how that might affect the microbiome and energy harvesting. They have looked at some individuals with anorexia nervosa, which is maybe the closest model for long-term energy restriction, but most of them are in animals that hibernate, and so we really can't translate that to is that the same thing as is that similar to chronic dieting because they're really sedentary. So the jury is still out on whether the microbiome plays a role in the increased energy absorption. It could be that maybe a person has reduced their carbohydrate intake, but they have a concurrent elevation in their fiber intake, and so they're providing more microbe accessible carbohydrates, and perhaps the net loss of energy in their stool isn't enough to overcome the increased energy harvesting. That is still a question that absolutely remains to be answered, but it's definitely worth pointing out that a lot of times people are confused because they're my calories are super low and I'm still exercising. But it's you really want to look at what else is going on, how intensely are you moving around in the other areas of your life, especially if you work at a desk or something. Sometimes I've seen people who are only taking 2,000 or 3,000 steps a day, And yeah, they're still working out like they have been for the last 5 years. But like in the last year, they're like, gosh, what's going on? You know, nothing else has changed. Well, except for you've gotten an office job or whatever it is, and you're sitting a lot more. So that's the biggest thing that I think is important to look at, is that your metabolism has probably not slowed down. Yeah, sure, you can go get your thyroid checked. I mean, that's not a bad idea at all, just to be sure, just to be on the safe side. But if that's come back normal and you're feeling really confused, just take a look at the other areas of your life, like how active you are outside the gym.
Yeah, and this is why I also want to highlight that the 100 to 150 calories per day that you extract less from your food when you eat the wholesome diet, it actually adds up over time. So when you are dieting, eat more of those foods. And this is why I get people to track their steps as well, because as soon as someone tries to lose weight, I'm doing this and this and this and this and this. Okay, cool, cool, cool. We know that. What's your diet like? What's your activity like outside of the gym? And not just on the weekdays, but the weekends as well, because all of that is really important. How can exactly over, well, actually, we'll do both positive and negative. How can dieting and exercise impact the gut and then bring stress into it? Because one of the passionate topics that we both share is negative body image and fearing foods.
Yeah.
I really want to highlight how fearing food can actually lead to more severe consequences on the other end, because that's like a stress response in your gut.
Oh, for sure. Yeah. There's really a lot of emerging evidence now that psychological stress has an impact on GI